What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at unequal tree diagrams. So this is where we've got a multiple step probability question, but for these ones we're not looking at equal chances. So these are weighted probability questions. Because we have gone through tree diagrams before, talking about how to set them up and work out calculations using it, we're not going to go into a huge amount of detail in this lesson about how to set these things up as a whole. Please have a look at my last video in order to really nail the basics down before we get into this lesson. So using the tree diagram for questions that are without replacement, so the sample space is changing every time, is really helpful. It just allows you to kind of visualize what the answer is going to be without having to make huge logic leaps during the question. And my favorite thing about tree diagrams is that it helps you really understand the order of a question. We could be looking for one specific thing to happen, but it might happen first, second, or third. And how do you kind of account for those in your probability mathematics is really important. Reading it off the tree diagram is a great way to get these marks straight away without having to do too much work. So the question we're going to use as an example is one of those favorite boxes of chocolate. Right, so for this example, we've got 6 flakes, 5 crunchies, and 2 boosts, and you're going to pick one out at random, have a look at it, and then pick another one. So this is a without replacement question. You're probably going to eat it halfway through, and we just want to see, hey, what are the probabilities of certain things happening? The first thing we always want to do for these questions is please add up the total so you know what the sample space is to start off. So because we've got 6 plus 5 plus 2, we've got 13 chocolates in total in the box, and this is what we're going to use as the denominator for our first step in this question. So the place that I'm going to start with these is I'm going to put a dot down and draw 3 equally spaced lines going up through the middle and down. Remembering that making sure that these lines are the same length will just help you out so much because it makes it way harder to kind of get confused as you're going along. Again, we've got to put the outcome that is happening at each side. So we've got flake, crunchy, and boost, and they're going to be F, C, and B. Now, the one thing that changes between the equal tree diagrams that we've done before and these ones is that I want you to write down the probability of that outcome happening on the line or the branch of this tree diagram. So not at the end where we've got our letter. I don't want it to be too cramped, but I'm going to write here 6 over 13, 5 over 13, and 2 over 13 on the branch so I can see exactly what the probability of that outcome happening is every single time. From here, we've recorded our first chocolate that we've taken out. Now to take the second one, we have 3 options off each other outcome. So we're going to have 9 in total. So we've got to draw those 3 lines off the F, off the C, and off the B. Again, making sure that we are taking the time to put it in order so the vertical line is right there. Again, it will just help you out when you try to read it to analyze some of the questions. Once you've got those lines down, what you have to do is put the new probabilities of each outcome happening on the lines again. Exactly the same as the first step. But you do have to go super slowly here. Because the sample space has changed, all of these are going to be over 12. But because I took a flake in the first one, instead of having 6 over 12, I need 5 over 12 for that second step at the very top. But because I took a flake in this example, the other 2, the crunchy and the boost, stay at the exact same. I've got 5 and 2 in this example. So when you go through these, make sure that the letter before, so the F, has now changed in your second one. So the F's going to change only after a flake has been drawn. And for this next one with the crunchy one is the one you have to take a little bit more time just to make sure that you have accounted for, hey, I've already eaten one. In exactly the same way as we did with the last tree diagrams, I want you to write out the outcome list at the end of your tree diagram. This will just help you immediately see what outcomes are possible. So we've got flake, flake, flake boost, flake crunchy, all the way down. And this is just going to help you see when the question says, oh, how many of these outcomes have a boost? You can just read it off incredibly quickly without having to kind of think or draw lines in order to see what information is needed. And now before we go on any further, what we're going to do is work out the probability of each thing happening immediately. So you might not have to do this, but I really recommend doing it because it just means you get all your calculations done straight away, and then you can just read off your answers in order to get the questions correct. So straight away, if I wanted to work out what the probability of a flake then a flake is, I've got 6 over 13 multiplied by 5 over 12, which is equal to about 19%. Now I'm going to do this for every single one. So the probability of getting a flake then a crunchy is 6 over 13 multiplied by 5 over 12, again equaling 19%. So these two outcomes are equally likely. For this third one, I've got flake, which is 6 over 13 multiplied by the boost, which is now 2 over 12, and this is equal to about 8%. So you can see how this goes. As long as you follow each branch and then write down the 2 steps of the probability of A multiplied by probability of B, you will get these right every single time. And you will start to notice a pattern pretty quickly with these ones. Okay, the more likely things off the first branch, so the flake, have a higher percentage of happening than those that come off the boost, which just makes a lot of sense. So now we could get questions like this. What is the most likely outcome? So I've got 3 of them, flake, 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 crunchy, and crunchy flake at 19%. If the order didn't matter for this question, you would say, hey, the most likely outcome for you is that you're going to have a flake or a crunchy in any order. And this is going to happen not 19% of the time, but 38% of the time, because I can add those 2 probabilities to get the final answer. So my most likely combination of chocolates in this experiment is a flake and a crunchy. And it does not matter the order for this one. This is where these tree diagrams can be really, really helpful, because you can just see straight away what the outcome list is and then get your answer from there. It also helps out when we've got a double. For this question, we're looking for, hey, what's the probability of 2 crunchies? And this is incredibly easy. So we've got 5 over 13 multiplied by 4 over 12, which is equal to 13%. That's all you've got to do. Happy days. Now, these ones are where it gets a little bit harder. Hey, what's the probability of me getting at least 1 boost in this question? So the first thing I want you to do is underline all the outcomes that have a boost in them, right? That makes sense. These are the ones that we want to look at. Then, because I've already got the percentage of these occurring written down, I can just add them up, and that's going to be my answer. So from here, I've got 8% plus 6% plus 8% plus 6% plus the 1% of getting 2 boosts, and that's all I need to do. Again, with these questions, please make sure you are really paying attention to the rounding and the question that's asked. If your teacher asks for an exact value or to 2 decimal places, just make sure that you are accounting for that, maybe using the fraction answer, not the percentage answer. I'm just doing this in order for you to see like, oh, I can see exactly what the percentage or probability of this is, but you might need to use the fractions in order to get full marks. So for this one, once you throw them in, 29%, that makes sense. Probably we're not going to get a boost every single time because there's only 2 of them in the packet. So having less than 50% chance makes sense. The last one here is, hey, what's the probability that I get 2 different ones? And instead of adding up all the percentages of those, I'm going to use the complement. I can find out the probability of getting the same, flake, flake, crunchy, crunchy, boost, boost, and then minus that percentage from 100%. So 19% plus 13% plus 1% is 33%. So in order to find out the answer, I'd just do 100 minus that 33. So I get a 67% chance that I'm going to get 2 different chocolates. So these questions aren't too difficult, right? The most important part about this is the setting out. If you get that correct, you will get these ones right. These kind of questions are also always worth like 4 or 5 marks. So if you do the setting out, you might get 3 marks accidentally without having to do any maths. So please take a little bit of time to set out correctly. Take a ruler in and use it, and this could really help boost your scores without having to do too much extra work. The other thing that I do want you to be really careful of, I did mention it before, but just make sure that your rounding at the end is really kind of solid, right? You don't have to put the percentages there, right? I just did that for visuals, but I do think it really helps out and makes your maths a little bit easier at the end. There's less use of fractions, which is always kind of nice. But the main point is that the rounding has to be on point in order to get full marks. So you're not kind of losing one just because you made a silly mistake rounding. I do hope you found this lesson helpful. Thanks so much for watching, and I'll see you later.